Hi students, this is Dr. Joa. In this recording we're going to learn how to name ethers, epoxides, thiols, and sulfides, and talk about the properties of ethers. So just a little bit of an overview. The McMurray textbook that we use tends to use common naming for ethers, but here I will cover from a variety of textbooks the nomenclature that's both IUPAC and common. So as you know, ethers are oxygen bonded, singly bonded to two carbons. They're organic derivatives of water. At the bottom here, I have examples of three of the most common ethers: diethyl ether, which we use as a solvent in tetrahydrofuran, THF, which we also use as a solvent. And then the simplest aromatic ether, which is commonly known as anisole. So let's talk about these naming conventions. From a blank page. Okay, so let's start with simple ethers. Just two alkyls. The IUPAC nomenclature for this is to name it as an alkane. So an alkane with 1, 2, 3, 4 carbons in its longest chain, and then a methoxy substituent. So this is a 1-methoxybutane. But the common name is a little bit simpler than that. It's just by naming the two substituents bonded to the oxygen in alphabetical order. So we have a butyl and a methyl. 3 words with spaces: butyl, methyl, ether. We're not going left to right or right to left here. We're just listing the substituents in alphabetical order. The simplest of ethers. The IUPAC name is, I have never heard anybody use it. It's ethoxyethane, but the common name is diethyl ether. And we'll just use the common name here. So there is a space there, that's 2 words. So we'll skip the IUPAC name for diethyl ether. And for other symmetrical simple ethers like dimethyl ether, we're gonna skip the IUPAC name and just use dimethyl ether. I can't put the name on there, but two words, dimethyl ether. There we go. So that's simplest of aromatic ethers. I'm going to redraw it here and give you the common name and the IUPAC name. So the IUPAC name, we're going to name this as a benzene with a methoxy group. So when, OCH3, that's methoxy. If it was oxygen bonded to an ethyl, that would be ethoxy, propoxy, butoxy. So this is methoxy. This is probably the most common. All one word because it's IUPAC, benzene. This has 2 common names. There's a methyl substituent in the oxygen and a phenyl substituent in that alphabetical order. So this is methyl, space, phenyl, and then the word ether. Okay, but then this has an even more common name, which is simply anisole. So there's nothing systematic about anisole, it's just historical. Now what if we have an ether that has other substituents? We can still use common names and IUPAC names. So that is an ether and it has a chloro. We treat the halides just like we treat alkyls when naming them. So this is a chloromethoxymethane. So the longest chain is a methane. If it was 2, it would be ethane. If it was 3, it would be propane. And then we would have to indicate what carbon this would be on. So actually, let's go ahead and do a propane here. CH2, CH2, CH3. All right, so 1, 2, 3. So that's a propane with a chloromethoxy on carbon 1. So this is going to be 1. Chloromethoxy. And we're going to put that in parentheses to indicate that the chloro is coming off of the substituent and not part of the longest chain. Now, because it is a methoxy, we don't have to indicate the 1 because it can be anything else. This is IUPAC nomenclature, so we don't have any space, and we name this as a propane. If we use the common name, so I'm doing an IUPAC at top and then common name at the bottom, again, we're not going to indicate the 1 on the substituent. This is going to be a chloromethyl, that's one word. And then second word would just be, oh, excuse me, I'm sorry, I forgot we changed this. Change this to a propane. Chloromethyl, well, that might change my naming. Nope, okay, good. Propyl, so it's a substituent now of an ether. Okay, so that's my 3 words. That's the common name there. Okay, here's the cyclohexane with an ethoxy substituent. So the IUPAC name here, we're gonna number this carbon 1 and this carbon 3 to get the lowest number for the most substituent. So then that would make this a 3-ethoxy dash 1,1 dimethyl cyclohexane. So we're naming these as alkanes or cycloalkanes with substituents on them. Okay. One more here. Okay, so here we have 2 functional groups. We have an OH, a hydroxyl group, and then we also have an ethoxy. So do we name this as an ether or an alcohol? Because alcohols are more common, we're going to name it as an alcohol. So we're going to give that priority. So this is going to be carbon 1 because it has the OH group, and this is going to be carbon 2. Since we're naming it as an alcohol, we're going to give priority to the group with the OH. And we are naming it as an alcohol because alcohols get priorities over ethers. So at carbon 2 of that alcohol, there's an ethoxy. Okay, and then this is an ethanol. Because it is ethanol, we don't have to call it, well, actually, never mind. That's the end of that. Okay. Let's look at some other molecules that have very common names. Okay, so the IUPAC name here is 2-methoxypropane. And so 1, 2, 3, 2-methoxy. But the common name is more common than the IUPAC name. There's an isopropyl, and you definitely want to memorize that common name for that substituent, isopropyl, and then methyl on the other side, and then ether. You can probably guess what the other common substituent that I'm going to draw is. This is 1, 2, 3, so there's a 2-methyl and a 2-methoxy. Methoxy gets listed first because of alphabetical order, so O comes before Y. So 2-methoxy, 2-methyl, oh, I'm going to run out of space, propane. There we go. Oh, I guess I can write over there. Okay, and then the common name, we have a methyl and then a terbutyl. So we ignore the T in alphabetical order. If there's a dash, you ignore it. If there's not a dash, you take it into account. So like for isopropyl, we do take it into account because there's no dash, but for terbutyl, we don't take it into account because there's a dash. So terbutyl, space, methyl, space, ether. You definitely want to recognize terbutyls. The last one that has a very common name, well, I guess there's two more that I could draw, but I'm only going to draw one here. 1, 2, or 1, 2. So this is, ethylene. So the question is, which way do we number it? Well, we're going to number it given the lowest number to, oh, it doesn't matter. I'm sorry. It wouldn't matter. It would have to be longer than 2. Sometimes I do this. I get ahead of myself. So this would just be a methoxy. It can't be a 2, right? It has to be a 1, no matter what. Methoxy ethylene or methoxyethene. Ethylene is actually a common name, but it's accepted by IUPAC. So methoxyethene is also IUPAC. It's the more correct IUPAC. The common name here would be methyl vinyl ether. So the vinyl is the CH2 substituent. Okay, and just continue doing examples. You're trying to cover all the bases. Okay, so we're going to name this as a cyclohexene. So we're going to give priority to the alkene, okay, over the ether. Basically, the IUPAC gives priority to the more reactive groups. So we're going to number this 1, 2, 3, 4, so that we come to the terbutoxy group be faster than if we went to number 1, 2. Oh, I guess it doesn't matter. 1, 2, 3, 4, but 1, 2 to get to the double bond. So the double bond there, the double bond there is what's deciding the 1, 2. Okay, anyway, at 4, there is a terbutoxy. And then we don't indicate the 1, 2 because it's understood by the fact that this is an ene, so cyclohexene. Okay, so on the previous slide, I was talking about common substituents. So let me make sure I include the allyl here. So this is allyl in vinyl. So this is allyl on the left. And then this is vinyl ether. And because this is a diene, we're not gonna dive into the IUPAC names. There is a space there, I drew them kind of close. I just want to do one aromatic. We haven't covered aromatics yet, just naming, but I do want to show just one here. So these are 4-dimethoxy. I'm going to name this as a benzene. Okay, so I just want to briefly mention the furans. This molecule is furan. It's the parent furan. This molecule is hydrogenated, so we call it tetrahydrofuran, or THF. Okay. If we had other substituents in the furan, we can number them, starting giving priority to the oxygen, 1, 2, 3. So this would be a 3. Oh, let's make it a methoxy just for fun. 3-methoxy furan. Epoxides, I just want to point out dioxane. So we're not going to name other dioxanes just the parent dioxane because it's such a common molecule. All right, now let's name epoxides. The naming of epoxides has 3 conventions, so it gets quite complicated. So the first convention, call number 1, is naming as derivatives of alkenes, which works for many epoxides. Derivatives. So the simplest of the epoxides is ethylene oxide. 2 words, ethylene oxide. Okay? From the alkene that it is made from, ethylene. So we just put the word oxide. This is also called oxirane. Okay, so that's the a second nomenclature that we're going to learn. And then the third nomenclature that we're going to learn, it's just naming them as epoxy. Which, because this is the simplest of the epoxides, it doesn't really have an epoxy name. Well, I guess it would be epoxyethane. Yeah, I guess it would be epoxyethane. But anyway, I digress. Let's go back to naming as derivatives of alkenes. So from cyclohexene, this becomes cyclohexene oxide. This gets slightly more complicated. Okay, if we take this and draw the alkene derivative, or that this was derived from, okay, including, you know, the correct geometry or the correct stereochemistry, although easy won't apply here because we have 2 ethyls on this other side, and we'll get to examples like that. But if we were to name this, we would number 1, 2, 3, 4, 5, 6. This would be a 4-ethyl, 2-methyl, 3-hexene. And when we name the epoxide, we're going to name it almost completely like that, but we do have to indicate that the epoxide is on carbons 3 and 4. So 4-ethyl, 2-methyl, dash methyl. And then we have to indicate that the oxygen bridges 3 and 4 because it could bridge other carbons, hexene, even though it would change the numbering. And then we add the word oxide. So 4-ethyl, 1, 2, 3, 4, 5, 6, 4-ethyl, 2-methyl, 3,4-hexene oxide. So the oxide of hexene. Okay, so that's as complicated as it's going to get, that nomenclature. Let's see if I have more examples. Okay, let me introduce the other nomenclature and then we'll do more examples naming everything. So number 2 is epoxy substituent naming. And we'll give some stereochemistry here. And then I'll put a methyl and a dash here. So we're going to name this as an epoxy substituent, and the epoxy group and the methyl are trans, so we can indicate that stereochemistry. So this is going to be trans, 1, 2, 3, 4, 1, 2 epoxy, so E before M. So we're going to list the epoxy substituent before the methyl substituent, and then cyclohexane. So this is like the IUPAC nomenclature for the ethers, but now it's an epoxy rather than like a methoxy or yeah, or an epoxy. Let's put some substituents on here. So when drawn like this in this orientation, everything looks flat, but this substituent and the substituent are both down, and then the hydrogens there are both up. So this is cis, and we want to get to the epoxy sooner. So rather than numbering from this side, we're going to number from this side. 2, 3, 4, 5, 6. So we're going to give priority to the epoxy over the methoxy. So this is going to be cis 2, 3. We list the epoxy first, not because of the numbering, but because of the lettering. E before M. And then 4 methoxy. Oh, no space. And then also hexane. So let's see. Okay, so then let's go ahead and move on to the oxirane naming. So this is naming number 3 as oxiranes. So as I briefly mentioned, this is oxirane. It's ethylene oxide. Oh, it's 1,2-epoxyethane. Okay, so now we know how to name that as a substituent of an alkane, and then just oxirane. I really like the oxirane naming. I think it's more intuitive than the other two and a little bit easier. So in the oxirane naming, we number the 3 atoms in the ring. The oxygen is going to be number 1, and then the carbons are going to be 2 and 3. So this carbon is going to be 2 because we come to 2 substituents, and then this is going to be 3. Okay. So you can see the previous naming for the IUPAC naming. If we name this as an oxirane, we're going to name it 2,2-diethyl. So we're saying at atom 2, there are 2 ethyls. At atom 3, there is an isopropyl. Yes, an isopropyl is also a 1-methyl ethyl, so you could put that in parentheses. If you forget the common name, just open parentheses, 1-methyl ethyl, close parentheses. But isopropyl is also acceptable, always. And then just the word oxirane. So we're naming this as an oxirane. All right, let's do some more examples and then try to name them as everything. So all 3 conventions. Okay, which one? I can't remember which one we did first. So this is going to be trans because that methyl is up, there's a hydrogen pointed down, and then this methyl is down, and there's a hydrogen pointed up. So this is going to be trans. Oh, let's put a methoxy here. Just to continue driving the point home, what gets priority? So the methoxy's down, that makes this 1, 2, and 3. So we're going to name it as a propene oxide, so trans 1-methoxy. Then we're going to list the where the double bond is, 1,2-propene oxide. Okay, so where did I get that from? So imagine the alkene that came, that epoxy came from, right? It would look like that. It would have to be trans 1-methoxy-propene, or yeah, 1-methoxy, 1-propene. So we had to list the 1, 2 trans 1-methoxy, 1-propene. The second naming, so as an epoxy derivative, still trans, 1,2-epoxy. There is a 1-methoxy, and this is a propane. So not as a derivative of an alkene, but as an alkane with an epoxy. And then the last convention, still trans. Oxygen is carbon 1 now. Or excuse me, oxygen is atom 1. So then we have a methoxy at 2. We're going to give priority to the methoxy over the methyl. So 2-methoxy, 3-methyl oxirane. Okay. You can go back and see the naming for this in the previous examples. I think I have just one more example. I want to include an example in which a substituent has a double bond. And so if we think about the alkene, that would actually be a diene. Okay, so we're not going to name it as a derivative of an alkene. We're just going to use, so we're going to skip that convention, but we're going to name it as an epoxy substituted compound and then as an oxirane. So this is trans, one group is up, one group is down. 1, 2, 3, 4, 5. So we're going to prioritize the double bond over the epoxy in the numbering. So trans 3, 4 epoxy, and we're naming this as a pentene. So because we're naming this as an ene, we're going to prioritize the double bond over the epoxy. The epoxy is a substituent. And then last is the oxirane. So 1, 2, 3. The oxygen is always going to be 1. And I don't have a good reason why this is named like this on the book. Okay, so we have a 2-vinyl, 3-methyl oxirane. All right, so that's it for the epoxides. The last ethers that I want to talk about are the crowns. Actually, all right, and last but not least, let us name some thiols and sulfides. So thiols are the sulfur derivatives of alcohols, and sulfides are the sulfur derivatives of ethers. So the functional group SH is called the mercaptan group. So just like we call a hydroxyl group, we call this SH a mercaptan group. And this quickly just means that that bond goes to something else. So first let's name simple thiols as derivatives of alcohol. So if this was an OH, this would just be 1-propanol. So we're going to name this 1-propane thiol. No space. And then it looks like a little bit of a space there. So it's like we snuck in the THI. So again, if it was an oxygen, this would be cyclohexanol. So this would be cyclohexane, thiol. So not quite not quite just sneaking in the thiol, but to keep it from sounding odd, we do finish cyclohexane thiol rather than cyclohexanol. If this was a substituent, then we would name it as a mercapto. We have not officially learned to name benzoic acids, but this is benzoic acid with a mercapto. So this is mercapto benzoic acid with a space between the two words. And then just one simple one. Now we're going to prioritize the mercapto group over alkyls. 2, 3, 4. So this, think about it, 3-methyl, and then 1-butane thiol. Okay, and then just to really conclude and wrap it together with this chapter, our sulfides are the sulfur equivalents of ethers. So this would be dimethyl sulfide. So from dimethyl ether, from that common name, and we're just going to use the common names. We're not going to use the IUPAC names here. Here we have a methyl and a phenyl in alphabetical order. Methyl space, phenyl space, not ether, but sulfide. Okay, and let me just give you one more example with an alkene because they're so prevalent. We do want to make sure we learn how to name these. So this is going to be a cyclohexene. Okay, the SH group is not a mercapto. If this was an SH, and I can write that here, this would be 1, 2, 3, 3 mercapto. Cyclohexene. Yeah, so that is a thiol, but we're prioritizing the double bond. Now, back to the molecule that I had drawn, which is a sulfide. Okay. The methoxy equivalent of a sulfur, I guess, would be a methyl thiol. Right, so if this was an oxygen, this would be a methoxy, right, a 3-methoxy. But this is going to be a 3-methyl thiol. Other than, I don't know why not call it a sulfoxy. Well, methyl sulfoxy? Yeah, I don't know. Anyway, I don't get to come up with the names. And then cyclohexene. All right, that is all I have. Enjoy your naming. Okay, this slide is just an overview of all the cyclic ethers, the epoxides, oxiranes, and then we mentioned the furans and dioxanes. And so those are the ones that I really expect you to memorize. But then we also have parans, which come up every once in a while, and then the oxetanes, which may come up every once in a while. Right, so now that we've covered naming, let's briefly talk about the properties of ethers. So ethers, as I mentioned, are really good solvents, and the reason for that is that their reactivity is so low. Ethers only react with strong acids, and they have to be really strong acids. So like HCl is not strong enough. We need like HBr and HI. So they're very good dry solvents. So if we draw our ethers with our oxygen, 2 bonds and 2 lone pairs, we get a bent geometry. And so we get a dipole. Now we could do that 1 arrow test and just draw the dipole of the molecule. So they are polar molecules. So here is dimethyl ether and diethyl ether. You see the dipole moment. It's significant. It's not water. It's not as polar as water, but they are polar solvents. They are polar molecules. So they're really good at solvating those cations and those crown molecules that we saw. And these are, again, experimentally determined. right? So here's just the same thing that I've drawn, showing that dipole moment. Now, because they lack hydrogen bonding, they are not as high boiling as alcohols. So if we look at similarly sized molecules, diethyl ether and then N-butanol, right? So they have the same molecular weight. Diethyl ether does not have hydrogen bonding, but butanol does. So the strongest intermolecular force in diethyl ether is a dipole-dipole interaction, and in N-butanol is hydrogen bonding. And because diethyl ethers have weaker intermolecular forces, they have lower boiling points. And the alcohols have higher boiling points. We have to compare apples to apples so that they have to be similar molecular weight. Ethers can be classified as hydrogen bond acceptors, even though they are not hydrogen bond donors, because they don't have a hydrogen. So a hydrogen bond is possible for molecules that have a covalent bond between hydrogen and either fluorine, oxygen, or nitrogen. So obviously ether doesn't have that like an alcohol, but I want to introduce you to this idea of hydrogen bond donors and acceptors. So alcohols are hydrogen bond donors and hydrogen bond acceptors. So here the alcohol is a hydrogen bond donor, okay? And here, well, there's not an example of, and then here the alcohol is a hydrogen bond acceptor, right? So that's not possible between two ethers, but if we mix alcohols and ethers, the ether can accept a hydrogen bond, okay? So it's a hydrogen bond acceptor. And so that really helps them be miscible with alcohols and other molecules that have hydrogen bonding, like amines. Okay, now the ethers, because they have our electron-rich oxygen, are going to act as nucleophiles in a variety of reactions, but again, they react very slowly. They react only with strong acids, the strongest of the strong acids. Okay, so as mentioned, our ethers function as solvents, and they're really good dry solvents, like for our Grignard reactions to both make Grignards and use Grignards. Okay, I guess I'm not writing. Okay, there we go. So here's just a list of a couple of different ether solvents, just to add to what we've seen: glyme and dioxane. Now at the bottom here, we can see ethers solvating cations. So their ethers are polar molecules, and the delta minuses can line up to solvate cations. Commonly, this is seen with lithium. It's very useful. And then we know that BH3, because it's electron poor at boron, is often stabilized by THF as the solvent. Okay, so here are our crown ethers. So a crown ether is an ether that has multiple oxygens bridged together by ethyl groups or propene groups. So here we have the 12 crown 4. The 12 refers to the total number of atoms in the ring. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the 4 refers to the number of oxygens. And the alkyl bridges need to be evenly distributed for this nomenclature. So there's a 12 crown 4 here that is solvating a lithium ion, a 15 crown 5 that is solvating a sodium ion. And lithium is smaller than sodium, so we need a bigger crown for the sodium. And then potassium is bigger than those other two, so we need an even bigger crown to solvate the 18 crown 6. So there are 18 atoms and 6 potassium solvating that cation. Here's an example of myself using 18 crown 6 to solvate a potassium. So that's a crystal structure there. Okay, so do plan on being able to, name your 18 crown sixes or any crown, just total number of atoms, the word dash the word crown, dash the number of oxygens.